The last topic we're going to discuss on Category 1 is factoring and dividing polynomials. So once again, this will be on your formula chart, but it reminds you what a perfect square trinomial looks like, a plus b or a minus b squared. We just did one similar on the polynomials, that last problem that was a perfect square, 3a plus 4. And then also a good reminder is the difference of squares. So when you have the difference of two perfect squares, I think the first one we're going to look at is exactly that. We have a difference of two squares. So as we look at it, remember, if I have two terms and it's the difference, I would ask myself, is x squared a perfect square? Can I multiply something by itself to get x squared? And sure enough, I know x times x, well, that's x squared. Is 25 a perfect square? Can you multiply a number by itself to get 25? Absolutely. 5 times 5. So when we have the difference of two squares, writing the factors is pretty simple. All we have to do is set up our two factors, or two things to multiply together to get this product. We know to get a difference when you multiply, we would have to do a positive times a negative. That's what would result in the difference, or the minus. To get the first position in each, you would say what times what is x squared? We just said x times x would result in x squared. And then in the second position in each set of parentheses would be 5 times 5, because 5 times 5 is 25. So if you were to multiply these two binomials using that rectangle or area model, you would find it equals x squared minus 25. On the second one, you have a binomial divided by a monomial, or a single term. So on this one, we could simply think about that don't break my heart. So we would say 16x to the 7th divided by 4x. 16x to the 7th divided by 4x. Now this is a exponential law, it's division. So remember, 16 divided by 4, we still treat numbers the same as 4. X to the 7th divided by x to the 1st, division law, says we subtract exponents. So 7 minus 1, we get x to the 6th. Then we need to do the negative 36x squared, still divided by the same denominator, 4x. Once again, we still treat numbers the same. Negative 36 divided by 4, that is negative 9. X squared divided by x to the 1st. 2 minus 1 is 1, so it's just x, or x to the 1st. And there you go. There's dividing polynomials. We have a trinomial. We need to find the factors. So remember, we multiply first times last, but we'll sum to the middle of negative 12. So 4x squared times 9, I know that that equals 36x squared. So in our calculator, remember, we can go to our y equals and do 36 divided by x, and in y2, we could do 36 divided by x plus x. Remember, all this does is help us find the two numbers that will add to get the middle term, but still multiply to get 36. So when you look at your table, second graph, we're looking for this y2 value that sums to get the middle term. So we're looking for the last column to sum to negative 12. Whatever those two terms are, those are our two x terms that we're ready to write and set up our box method. So we would set up our box. We could fill in first term, 4x squared. Last term was positive 9. And then when I find these two terms that are split, we could write those into our box method. The last thing you would do is find the GCF of the top row, the greatest common factor, and then you would find the rest of the numbers to multiply together to get the inner four boxes. The next one is, remember, we have x plus 8 times 3x plus 5 divided by x plus 8. Well, this is already in factored form, and we know anything divided by itself is 1. So this one's simple because x plus 8 divided by x plus 8 is just 1. So all we're left with is 3x plus 5. This is very similar to the previous, the one right above it. We're just finding the factors again. So it's the same process, first times last, but sums to the middle. That middle term, if it's plus x, is just remember positive 1. So 4x squared times negative 5. So in y1, that equals negative 20 divided by x. y2 would be negative 20 divided by x plus x. And then in our table values, we're looking for the last column to sum to the middle term of positive 1. So we're looking for these two terms right here that sum to positive 1. Once again, you would just simply set up your box method, fill in what you know, first term, 4x squared, last term, negative 5, and these two terms that you find in your table would be written here. So you can now find your two dimensions that multiply to get those partial sums. Last one is 7x squared minus 19x plus 10 divided by x minus 2. Now on this one, all you're going to have to do is do the same thing. You need to find the factors of the numerator, the two things to multiply together. Use the same strategy. So 7 times 10 is 70. So go ahead and do your calculator steps. And then when you find your factors, be thinking or look for something like this. See if you have a factor like x minus 2, not only in your denominator, but will cross out or 1 out with your numerator. And that should get you your final quotient on the last problem.